Voyager 1, the most distant human-made object in space, faces a crisis. The spacecraft, voyaging for nearly 5 decades, encounters significant difficulties in sending data to Earth. It spontaneously transmits an unusual sequence of 1S and 0S, baffling observers. Engineers and scientists are now diligently working from a distance of 24 billion kilometers to diagnose and rectify the issue. Their aim is to ensure the continuation of this historic mission, allowing it to offer priceless insights from its odyssey through space. But what exactly is causing the spacecraft to transmit this mishmash of data? Is this just a small technical glitch or a significant malfunction happening in the background? Finally, and most importantly, considering the spacecraft's age and distance, is it even possible to address this issue? To address these inquiries, it's crucial to comprehend the reason behind the probe transmitting an unusual binary pattern. Similar to Earth's computers, the Voyager spacecraft utilizes the binary system for communication. It relies on only 2 digits, 0 and 1, to convey various types of information. Each 0 or 1 is termed a bit, and a compilation of these bits can symbolize anything from numbers and letters to more intricate data, such as images or sounds. Voyager 1 is equipped with 3 primary computers, and the issue is linked to 2 of them. The first computer, known as the Flight Data System, FDS, plays a pivotal role in gathering 2 types of information from the spacecraft. It collects data from scientific instruments designed for studying the universe and monitors the spacecraft's health, indicating whether all components are functioning correctly. After collecting this binary format information, the FDS processes and consolidates it into a singular data package. This package is then transmitted to the second computer, the Computer Command System, housing the Telemetry Modulation Unit, TMU. The TMU's role is to transmit this package back to Earth. To achieve this, the binary data is initially modulated onto a carrier signal for transmission to Earth. Once accomplished, the TMU transmits the waves carrying the data, which are received on Earth through the Deep Space Network, DSN. The DSN consists of large radio antennas strategically positioned around the Earth, such as in California, Spain, and Australia, ensuring continuous communication with various spacecraft as the planet rotates. Following the reception of binary data, it undergoes further processing in data centers. Eventually, the binary data is transformed into human-readable formats, such as numerical values, graphs, or images, which are utilized for analysis and research. For over 4 decades, Voyager 1 has shared information in this manner. However, the spacecraft's communication system has recently encountered a mysterious issue. Instead of transmitting the usual blend of scientific information and spacecraft health data, reports indicate that the Telemetry Modulation Unit, TMU, is emitting an unusual and repetitive sequence of 1S and 0S that appears nonsensical. NASA has not disclosed the exact pattern sent by the Voyager probe. In a preliminary report on the matter, NASA has determined that the primary issue lies with the Flight Data System, FDS. For an unknown reason, the FDS is mishandling the information. As incorrect data reaches the TMU from the FDS, it triggers the TMU to transmit irrational binary messages back to Earth. Typically, when faced with such a challenge, the initial recourse is to reboot the FDS by powering it off and then on again. This approach has proven effective in resolving various technological issues, both on Earth and in space. For instance, in 2010, Voyager 2 encountered a similar problem with data due to a bit flip, and the team successfully addressed it by executing a memory reset command for the FDS. This on-off procedure also rectified a glitch in the Hubble Space Telescope a couple of years ago. Following the same strategy, a reset was attempted on the FDS in this case, but unfortunately, it did not yield the desired outcome. The problem persisted upon system reactivation. Consequently, engineers and scientists are now working to devise more robust solutions. Yet accomplishing this task is more formidable than it may appear. Firstly, the spacecraft was constructed almost half a century ago by individuals who have long since retired. Therefore, the current team must delve deeply into archaic documents to comprehend the functioning of the probe and its computers. Despite several software updates over recent decades, the technology remains highly outdated. To draw a comparison, a contemporary cell phone in your possession can handle over 100 billion instructions per second. In contrast, Voyager's computers can process a mere 8,000 instructions per second. Furthermore, at Voyager 1's current distance, it takes nearly 22.5 hours for light to traverse one way to Earth. Consequently, whenever the team devises a potential solution and implements it, there is a 45-hour round-trip duration for the signal to reach its destination and a response to journey back. On a positive note, Voyager 1 has encountered similar challenges before. In 2022, the probe transmitted data through a malfunctioning onboard computer, resulting in corrupted outgoing messages. Nevertheless, NASA engineers identified the issue and successfully resolved it. The Voyager mission was not originally intended to endure for such an extended period. This remarkable mission, initially crafted for exploring the outer planets, has far surpassed its initial objectives, providing invaluable insights into the universe beyond our solar system. The probe relies on a radioisotope thermoelectric generator for power, which gradually diminishes over time. Consequently, the team managing Voyager 1 faces challenging decisions regarding which components of the probe to keep operational. The last images captured by Voyager 1's cameras were part of the Family Portrait series, taken on February 14, 1990. This collection featured the iconic pale blue dot image of Earth, depicting our planet as a minuscule point of light from 3.7 billion miles or 6 billion kilometers away, amidst the vastness of space. Following the capture of these images, the cameras and other non-essential instruments were deactivated to conserve power. The primary focus of NASA engineers is to sustain the functionality of the instruments responsible for transmitting data back to Earth for as long as possible. As of January 2024, only 4 out of 10 Voyager 1 instruments remain operational. The data transmitted by Voyager 1 holds critical importance, especially now that the probe traverses a region of space where the sun's influence is faint. It provides valuable insights into phenomena like cosmic rays and magnetic fields in an area we've never directly studied before. However, maintaining communication becomes progressively challenging as Voyager 1 ventures further. Signals take longer to travel, and they attenuate significantly by the time they reach us. Despite these hurdles, Voyager 1's odyssey persists. It doesn't have a specific destination, yet in approximately 40,000 years, it will come relatively close to a star named Gliese 445. While this time frame is extensive in human terms, it's merely a blink of an eye on the cosmic scale. One of Voyager 1's most remarkable features is the golden record it carries. Functioning as a time capsule, it contains sounds and images from Earth, aiming to showcase life on our planet to potential extraterrestrial beings who might discover it. The record also includes instructions on how to play it and a map indicating its origin. The concept was to share a glimpse of our world with any entities that might encounter it, even if that occurs millions of years from now. It's akin to casting a bottle into the cosmic ocean, conveying a message about who we are from a distant little blue planet. Therefore, Voyager 1's expedition is not solely a scientific mission. It narrates a tale of human curiosity and ambition. Despite the recent technical glitch, considering the achievements thus far, there remains hope for a resolution. If the issue is rectified, scientists anticipate the spacecraft to persist until its 50th birthday.